1.6 Graphical Transformations. Alright, transformations. Functions that map real numbers to real numbers. Rigid transformations. Leaves size and shape of the graph unchanged. Including horizontal translations. Vertical translations. Reflections. Or any combination of these. Non-rigid transformations. Distort the shape of the graph. Includes horizontal and vertical stretches. And your book calls it shrinks, but we've always said compressions. Okay, or that it's compressed.
Is that like the map of the U.S. like on a flat map? How it's like distorted? Or is that not related at all?
We're talking about math, not geography.
Back down a little bit.
So no, not the same thing.
I see.
I mean, non-rigid maybe, but not transformations.
Is this hard? Actually, don't
No.
ask me, because you say things are hard and then I'm so confused.
You literally have done all of this before, so no. Vertical translation is a shift of the graph up or down. Horizontal translation is a shift of the graph left or right. All right, translations. Let C be a positive real number. Following transformations result in translations of the graph of y is equal to f of x. Got horizontal translations y is equal to f of x minus c, which is a translation to the right c units. Y is equal to f of x plus c is a translation to the left c units. So with these, remember the shift goes the opposite direction of the sign. Vertical translations y is equal to f of x plus c is the translation up by c units, and y is equal to f of x minus c is the translation down by c units. So with this one, the shift goes the same direction of the sign. All right. Reflections. Okay. Try this again. Reflections across axes. So reflection across the x-axis. We'll give you the 2 points, something like xy and x negative y. Reflections across y-axis, give you points xy and negative xy. Reflections of each other across the line, 2 points. that are symmetric. With respect to a line
What is WAR example UT?
with respect to. Alright, so the following transformations result in reflections of the graph of y is equal to f of x across the x-axis. We would have y is equal to negative f of x across the y-axis. Y is equal to f of negative x. And through the origin, y is equal to negative f of negative x.
Is there a lot more?
Yeah, there's still stuff about stretches and compressions. The graph of an even function remains unchanged when it is reflected across the y-axis stretches and compressions. Let C be a positive real number. Then the following transformations result in stretches or compressions of the graph of y is equal to f of x. Horizontal stretch or compression y equals f of x over c. It's a stretch by a factor of c if the absolute value of c is greater than 1. Okay, so if it's like 1, 2, 3, 4, negative 5, 6, whatever. As long as the number itself is bigger than 1, okay, absolute value of it, then it's a stretch. It's a compression by a factor of c if the absolute value of c is less than 1. Okay, meaning it's like a fraction or a decimal that's like not over 1. And then there's a vertical stretch or compression so y is equal to c times f of x. So it's a stretch.
Because the thing where you have the like little bracket thing, it says stretch by blank factor. Does that say C factor?
And it's supposed to be a factor. The
Okay.
glare is weird.
I see this. Thank you.
I don't know what's going on.
Oh.
There we go. Stretch by a factor of c if the absolute value of c is greater than 1, and a compression by a factor of c if the absolute value of c is less than 1.